Alright guys, so this is going to have the confidence interval stuff on there, right? So we got those. So you're not allowed to put notes on this, obviously, right? Some people, hopefully nobody loses points on the formula sheet this time. That would be a nice first for me, but we'll see. Yes, believe it or not, somebody always loses points somehow. One semester I had somebody who made up their own little language to themselves, and I'm like, no extraneous symbols that can mean stuff, no. It's just, I don't know. So, figured out your language, and this is notes. Stop it. So how is this a note, though? This I have to let you put this down there because it's formulas. It's a formula sheet, but how is this a note? This is a major note. This is a major note that you guys make mistakes on all the damn time, but the formulas are telling you what to do.
Oh, I was just saying, it tells you between t-scores and t-scores.
Yeah, when you use t-scores, when you know. Yes, it's in the formula. It's telling you. You use z only when you know sigma. Of course, to use anything, you have to know that the distribution is normal, and you must state that. Tell me why it's normal. And then, of course, we got this guy here. And then we got the two formulas for figuring out how large of a sample you need. Yes, sir?
Did we put how to get p-hat or
no? Yeah, that's the thing that I don't want to get into this big thing with you guys, but people used to come out of high school knowing how to deal with percentages a lot better than they do now. The word of, people don't have a clue what that means. You guys know what the word of means mathematically? As I shake my teeth. Huh? Multiplication, yeah. It was just, everybody just knew it. It was just a known thing. It was like knowing what the letter A sounded like. It's like you just come in knowing this. And now it's like at least half the class doesn't know what of means. And some of you guys are like, what's the big deal with that? Well, that's just fundamentals getting lost. So yeah, you got to know how to make a percentage. It's the part divided by the whole. That's, I don't mean to be yelling at you. Cool. But you can't. You're not allowed to put that up here. It's something I want you to know how to do. I like it. So then these guys here. All right. So that's all the stuff from chapter 8, the confidence interval stuff.
And we're not doing the two T-scores.
We're not done yet.
Oh, okay.
I'm just stopping for a second.
Is there a time ever that we only use z-scores?
Yes.
PQ.
Yes. For an NPQ problem,
Okay.
you always use z-scores because we're always creating our own standard deviation. So it's, yeah. So that's why there's only one formula here. It only has a z in it. Right? So as long as it's normal enough, and how do you know this will be normal enough? NP and NQ, bigger than 5, I like it. As long as it's normal enough, you can use z-scores. It's the sample means that have to use one of these two options, right, depending on what standard deviation we know. I like it. T-scores were invented to cover our ass for when we don't know the real standard deviation. That's why they were invented. So that's how I tell when to use them. All right. Then we have hypothesis tests. I'm not gonna just suddenly say do a hypothesis and not give you the steps. I'm gonna give you the steps, right? The 5 steps. The only real formulas you could put down are related to the z-scores, right? So I mean, I didn't let you do this earlier, but a few of you guys kind of crashed and burned on that. But I mean, you got to know this. If you've done enough homework, you just know these formulas. My God. And if I want to make a new standard deviation, I base that off of the old standard deviation. I don't divide the mean by square root of n. That doesn't make any sense. I take the old standard deviation, and alter it a little bit to create a new standard deviation. That's the idea in that formula. So a lot of us are putting weird things here and here. Yes, ma'am.
So in a problem, if we're given the standard deviation for whatever, can for like the sample mean problems for the confidence intervals, can we just put in, like, if we're only given the sigma sub x bar, can we put that in for sigma over the square root of n?
Yeah, if they gave you this, then yeah, that's what that is.
Okay.
Yeah. That'd be weird though. Did they do that to you in the homework?
I did that on the homework. They gave me like s sub x.
They just gave you this,
Yes.
which is not this.
Okay. What is just sub x?
All right. So guys, when you do one var stats on your calculator, how many standard deviations does it give you? 2. If you'll notice, they give you Sx and sigma x. So the standard deviation in my values, my variable values, this is the standard deviation amongst the individual values. So these are both standard deviations for individuals. These situations, I am taking a sample. I need the standard deviation of groups, not of individuals. So it's built into the formulas here. And it's kind of like a side thing we do here. And I could put it in there, and some of you guys do that, but then people put it in the calculator all wrong when you have a fraction inside of a fraction. So I try to break that up just to save you from yourself. But you can do it all at once if you're able to handle it. And then we have the other z score. You can put the z star if you want to there. And maybe even, in case this freaks some of you guys out, don't even put that there maybe. That just means the mean of the means, but it's going to be the same as the mean. It's the mean you see in the claim. That's what it's going to be. Yes, ma'am.
So just as a refresher, standard deviation x bar, that's when we're given the population standard deviation and then we had a sample, right? And we divided by our sample.
All right, so no matter what, if I have a group that I want to talk about, I take the standard deviation that's for individuals, be it a population standard deviation or a sample standard deviation, and I have to convert it to the one that works for groups. If I know sigma or s, you got to do the same thing. It's not all about population versus sample. It's about individuals, how much they vary, and groups, how much they vary. So I don't care which one you know, you got to change it from individuals to groups. So doing this doesn't make a sample standard deviation. No, it makes a standard deviation amongst groups. Same thing here. Baby. I get all kinds of looks. All right. And then we got these Z star formulas. We got the one for p hat. So here's a conceptual question I could ask. Do you guys remember where we got this from?
Along a clinical process.
No, from right there. Right? Why do these have hats and those don't?
Because
What is this fundamentally, this process? What do we not know here that we're trying to capture or get an idea of? The true population proportion. We don't know what it is. So if we don't know what P without a hat is, I got to use P with a hat. That's all I got. That's the best I got. Over here, I know what P is. It's in the claim. So I'm not going to use the hatted ones. That's a great name for a band. No. I'm not going to use the hatted ones. I'm going to use the one without hats. That's the population ones. Of course I'm going to use that whenever I can. So there are some homework problems where they give you S and they also give you sigma. Screw S. I'm using frickin' sigma. Shit, yeah. All right. Cool. Strange accent I got. Damn straight. All right. Z star, and then we have this one. I guess you could call it T star if you want to be all. Officially a T star because there's S's in there. I wish you guys, well, if you go further into stats, you'll get to the point where you realize T and Z are the same damn thing, really. Especially when we're just calculating. When we look at it on a chart, they still tell us the same thing, just in different situations. So, okay. Any other formulas you think we should be able to use?
So I guess this is something to know, but the freedom thing.
Oh, degrees of freedom. What is the degrees of freedom for this one? N1 plus N2 minus 2. Why does that make sense? Because for a single N, it's N minus 1. So now I got N minus 1 plus N minus 1. So that's why N plus 1 plus N2 minus 2 makes sense. If you forget that, just come up and ask me. I might put it on the test. We'll see. Don't forget, we stopped short of finishing section, where are we at? 10.5. We made it up to 10.2. So we don't, 10.3 will be later. So you only have to do homework up through section 10.2. Okay, good. All right. So anything else you think you should be able to put up on there? Yes?
P stars for samples. Just replacing as consideration sigma.
Oh, okay. Sure. I mean, you could put. Sure. Yeah, if it makes you feel better. I'm sorry. I don't mean to make. But to me, again, that is divided by the standard deviation that you have to work with, right? So sigma x bar, s x bar, whichever one you got, that's what you use. So officially, this would really be a T star, but again, the distinction is kind of silly. They're both just saying how far away from the middle is that relatively. So, okay, maybe, hopefully. Okay, but that kind of reinforces the idea. When you have S, it's a T. When you have sigma, it's a Z. So I like that. That's fine with me. All right. Okay. So anything else you want to put on that formula sheet? Now's the time to ask. Example problems? No. Notes? No. Okay. So now let's get into, let's do this. I didn't do the last problem on the practice test. I sort of ran out of room. So let's do that together. Has everybody got what they want from this here? Some of you guys are like, yeah? Want is not the right word, Jeff. There we go, what they need from this. There you go, all right. I don't get the weird faces. Okay. So let's do number 6. Number 6. Sure, you guys, if you want to, try to set at number 6. If you got something else you want to do, it's totally up to you. But and then I'll give you a few minutes, and then I'm going to do it up on the board. It's not on the answer key, so I want to do that up here. So bring with me number 6 on the practice test. If you want to do that right now, do it. If you want to work on corrections instead, feel free. We're coming. It's in the upside down heading.
Usually it comes with good.
Oh, because they gave you a list of data? Yeah. Yeah, of course.
Is it,
Yeah.
is it like a second?
Yeah, because we're out of that chapter where I made you do the tables and stuff. So you just put the list in the calculator, just write it down. Yep.
Yeah, because I'm if they call you with a pen, they obviously get it nice.
Could they leave us?
There's always like
Yep.
about writing.